Enterprise architecture starts with three foundations: principles that guide consistent decisions, stakeholders who reveal what matters, and requirements that define what is feasible. Together, they turn business concerns into target architectures we can evaluate in a real AI platform case study. So far, we've established the value of enterprise architecture and how TOGAF helps organize change. Now we move from framework concepts to practical guidance: principles, stakeholders, and requirements. These inputs help architects make decisions that are traceable, governed, and ready to apply in the upcoming Azure AI case study. Good architecture depends on the quality of its inputs. Principles set the guardrails, stakeholder concerns clarify priorities, and requirements turn intent into action. When these elements connect, architecture becomes traceable, defensible, and aligned to outcomes, not just well-designed. Architecture principles are stable guidelines that shape technology and architecture choices across the enterprise. They express what should guide decisions, so projects, products, platforms, and business units do not drift in different directions. In TOGAF, principles support ADM work by improving alignment with business goals, strengthening governance, and making design decisions more consistent and repeatable. Principles are not one-size-fits-all. They operate across domains, and each domain protects a different enterprise outcome. Business principles keep architecture tied to value, customers, priorities, and the operating model. Data and application principles make information trustworthy and systems easier to integrate, reuse, and change. Technology, cloud, and security principles support stable platforms, resilience, compliance, identity control, and risk reduction. AI principles add responsible use, explainability, human oversight, privacy, and model governance. The goal is consistency. Decisions may happen in different domains, but the principles should reinforce one enterprise direction. A strong architecture principle has four parts. First, give it a memorable name, such as data is a shared enterprise asset. Then write the statement as a usable rule, not a vague aspiration. For example, data must be defined, governed, and reused across business domains. Next, explain the rationale, why it matters to strategy, cost, risk, or agility. Finally, spell out the implications. Who must change behavior? What standards, funding, exceptions, or trade-offs follow? This is where principles become actionable, because decision makers can see the real commitments behind the words. Principles become valuable when they shape real decisions. A team may need to choose between faster delivery, lower cost, stronger compliance, or a more scalable design. Principles give that discussion a common frame. They help teams assess options, justify trade-offs, and decide when a standard should apply, or when an exception is reasonable. Governance also becomes stronger. Instead of approvals feeling subjective, the reasoning is visible and repeatable. Over time, that leads to more consistent architecture choices across programs. Architecture is shaped by more than technical choices. Each stakeholder brings a concern. The target architecture must answer. Executives look for strategic value and business risk reduction. Business owners care about process outcomes. Security and compliance teams focus on controls and exposure. Operations teams care about reliability, performance, and supportability. Product teams, developers, users, and data science teams each add their own needs. The architect's role is to make these concerns explicit, compare trade-offs, and avoid a design that works technically but fails organizationally. Stakeholder identification should be deliberate, not based only on who requested the work. Start with sponsors and executives, because they define outcomes, priorities, and funding. Then include delivery roles such as product owners, architects, developers, and platform teams, because they shape what can actually be built. Bring in control functions early: security, compliance, legal, privacy, risk, and audit. Finally, include operations, support teams, and end users. They reveal adoption, usability, and runtime concerns. Strong architecture decisions depend on hearing affected voices before choices harden. An enterprise AI platform is judged by many audiences. Executives ask whether it creates advantage, proves ROI, and reduces risk. Security and compliance teams ask who can access what, how data is classified, and whether actions are auditable. Data science and product teams need usable data, fast experimentation, strong model performance, and smooth deployment. Operations teams care about monitoring, resilience, incidents, and service levels. The architecture has to balance these concerns because a platform that delights one group but fails another will not be trusted in production. Requirements are the bridge between intent and action. A business goal, such as improving customer trust, creates stakeholder concerns like protecting sensitive data. Those concerns become requirements. Business requirements define the outcomes. Functional requirements define what the solution must do. Non-functional requirements define how well it must perform, including security, scalability, reliability, and usability. Architecture requirements translate these needs into design direction. For example, protect sensitive data may become encrypt data at rest and in transit using centralized key management. From there, architects evaluate options, shape the target architecture, and guide the implementation backlog. Architecture is never designed in a vacuum. Requirements tell us what the solution must achieve, while constraints define the boundaries of what is realistic. Some boundaries come from the business: budget, timelines, operating model, or readiness to change. Others come from technology: legacy platforms, integration dependencies, data quality, or available skills. Regulatory constraints add non-negotiables around privacy, security, residency, and auditability. The architect's job is to work within these limits, not ignore them. Often, that means designing a practical transition state first, while keeping the ideal target state visible. In TOGAF, requirements management is not a one-time checkpoint. It runs through the entire ADM cycle. As the vision, business architecture, systems architecture, technology architecture, and migration plans develop, new requirements are discovered and existing ones are refined. When an architecture decision changes, the requirement set must be tested for impact. Traceability connects each decision back to stakeholder needs and business goals, so teams can explain why choices were made. This makes requirements management a governance discipline, not just documentation. It keeps change aligned with value throughout the architecture lifecycle. Enterprise architecture rarely gives us perfect choices. Every decision creates a trade-off. Faster delivery may reduce control, innovation may increase risk, lower cost may weaken resilience, and flexibility may conflict with standardization. Traceability keeps those trade-offs honest. It connects a stakeholder concern to the requirement, the guiding principle, the architecture decision, the standard, and the implementation work. When conflict appears, architects should not rely on opinion alone. They test options against agreed principles, risk appetite, business value, and compliance duties. Governance then records the exception or approval, so the organization can see why the choice was made. Effective enterprise architecture starts with a practical foundation: clear principles, understood stakeholders, and actionable requirements. Principles keep decisions consistent across domains. Stakeholder concerns keep the work relevant and valuable. Requirements and constraints turn strategy into design choices that can actually be delivered. Next, we'll apply these TOGAF foundations in a secure enterprise AI platform case study on Azure.